Okay, to explain the answers to the following, or to the previous questions, you were asked to assign the oxidation number to the elements in each of the following. In magnesium chloride is an ionic compound. We know that because magnesium is a metal and it's paired with a nonmetal. So that's a pretty easy rule to follow. So you know it's an ionic compound. And by rule 3, ions have the same oxidation number as their charge. And if you remember from nomenclature, chlorine has a charge of -1 when it's in an ionic compound as a monoatomic ion, and magnesium is +2. Or else you could just use rule 5 that says that chlorine is assigned a number of -1 unless it's with oxygen or fluorine, and then use a little bit of math to figure out the charge on whatever metal it's paired with. Or in this case, I guess rule number 4, I think, and I'll have to look that up, but rule number 4 says that group 1 and 2 metals have the same oxidation number as their charge, which is +2 for group 2 metals. So magnesium chloride is covered by a lot of rules. Next one, in carbon tetrachloride, we know the oxidation number of chlorine because we have a rule for it, rule 5, but we don't know one for carbon. By rule 5, chlorine has an oxidation number of -1, so we have to do a little math. Now, by rule 1, the oxidation number of carbon plus 4 times the oxidation number of chlorine, or -1, has to equal 0. It's a neutral compound. So you do the math and you find out the oxidation number of carbon minus 4 equals 0. So it's equal to +4. And we find that by adding 4 to both sides of the equation. Now, nitrogen in the nitrogen molecule, N2, by rule 2, has an oxidation number of 0. It's in its elemental form. It is all by itself, meaning that it is not paired up with any other type of element. Okay. In phosphate ion, we know by rule 6 that oxygen has an oxidation number of -2 unless it's paired with fluorine, or no, unless it's just paired with fluorine. So we have to do some math to find out what phosphorus is, because phosphorus doesn't have a rule. So we're going to use rule 1 that says that the sum of the oxidation numbers of atoms in a polyatomic ion must equal its charge. So we know the oxidation number of phosphorus plus 4 times the oxidation number of oxygen has to equal -3. We do the math, we find that phosphorus minus 8 is equal to -3. If we add 8 to both sides, we end up finding out that the oxidation number of phosphorus is +5. Okay, the next question wanted you to find the oxidation number of some different atoms in compounds. The first was the carbon in carbon dioxide. Well, there is no rule for carbon, so we have to look at what it's paired with. It's paired with oxygen, and we know that has an oxidation number of -2 by rule 6, unless it's paired with fluorine. But it isn't, so it's -2. We'll do the math and say that the oxidation number of carbon plus 2 times the oxidation number of oxygen has to equal 0. Sorry. So carbon minus 4 is equal to 0. And you add 4 to both sides of that equation and you find out the oxidation number of carbon is +4. Now we have chlorine in dichloroheptaoxide. Once again, oxygen is -2, and you might be tempted to say that chlorine is -1. But chlorine is only -1 when it is not paired with oxygen or fluorine. And in this case, it's paired with oxygen, so we have to do some math. So We'll use rule 1 that says the sum of the oxidation numbers has to equal the overall charge of the compound. In this case, it's neutral. So 2 times the oxidation number of chlorine plus 7 times the oxidation number of oxygen has to equal 0. You do a little bit of math, you say 2, you find out that 2 times the oxidation number of chlorine minus 14 is equal to 0. Add 14 to both sides, we find out that 2 times the oxidation number of chlorine is equal to 14. Divide both sides by 2, and we find out that each chlorine has an oxidation number of positive 7. And finally, we have manganese in the permanganate ion. We don't have a rule for manganese, so we have to do some math. Oxygen, once again, is negative 2. So the oxidation number of manganese plus the 4 times the oxidation number of oxygen is equal to negative 1. Do a little more solving, and we find that the oxidation number of manganese minus 8 is equal to negative 1. We add 8 to both sides of the equation, and we find that the oxidation number of manganese is equal to positive 7.